Once the WinCam D LCM is set up and the DataRay software is running, you're ready to start profiling. To begin capturing frames, press Ready or the Go button here. 2D profiles are almost immediately generated. Here we have a false color 2D plot. Below we have two one-dimensional profiles. Each of these corresponds to one axis along the crosshairs shown here. If we right-click this plot, we can auto-orient the crosshairs or change them to some degree. This page has significant important information. The major and minor diameters are shown here, the mean diameter, the effective diameter, the ellipticity of the beam, the orientation of the beam, the orientation of the crosshairs, as well as the centroid location. You can change the centroid positioning from absolute to relative by clicking here. The ADC peak percent is located here, and the plateau uniformity is located here. At the top left, we have the option of selecting two different clip levels. If I click Clip A, I'm able to select 1/E squared, full width half maximum, 86.5%, or some other custom clip level. You can also select D4 sigma diameters here. The exposure time can be automatically adjusted, but in some cases, you might want to use a manual exposure time. You can right-click here and disable auto exposure adjustment, and then adjust the exposure time accordingly. At long exposure times, the sensor becomes oversaturated. The orange text shows these results are unreliable and either more attenuation or a lower exposure time is required. And now Lauren will show you some more features using an XYZ stage and the WinCam D LCM.
The current setup uses a 405 nanometer source that is collimated at 4.6 millimeters using a collimation lens attached to the fiber output. I can move the fiber up and down with its lens using the XY stage that I have mounted the fiber and lens on. You can see that there is large diffraction circles that are moving up and down with the beam. These circles are a result of dust on the lens, which I can tell is on the lens because it is moving with the beam as I move it up and down. There are also smaller diffraction spots. These do not move as I move the lens, and these spots are as a result from dust on the ND filter, which is attached to the WinCam D-LCM camera. You can see as I rotate the filter, those spots will move. It is recommended to remove dust using a stream of clean air. The beamwander dialog can be opened using the green target icon on the toolbar. It continuously records data, so I will choose clear to begin with a clean plot. The beamwander dialog plots the X and Y centroids on a target to track the position of the beam centroid across frames. I can move the beam left and right or up and down, and the beamwander dialog will show the path on its plots. You may want to disable averaging when recording a beamwander measurement if you would like to measure the beam stability of your laser, because averaging can average the centroid measurements, which you may not be interested in doing if you're measuring stability. Older points are darkened and newer points are shown in a brighter red color. You can also record beamwander in pointing angle instead of X and Y microns. You can do this by opening the Clip A level entry dialog and choosing Enable Pointing. Enter the source to imager distance, which the software will use to calculate the pointing angle. using the geometry of your system. The software will now display pointing based on the distance you entered and how far away the centroid is from the sensor of the sensor. You can also choose the relative centroid button and change um, what part of the sensor will correspond with a pointing of 0, 0. The pointing angle will show in the beamwander dialog in addition to the typical X and Y spatial distance measurements. The strip chart dialog is a useful feature to plot any of the output values the software measures over time on a graph that can be exported or saved. You open the dialog using the toolbar icon and choose up to 4 points for each of the plots to record. I will choose the beam width 2WUA, which is the beam width across the U axis at the clip A level. I will choose start to begin the measurements, and the diameter will record over time on the plots. I can begin to block the beam to artificially change its diameter, and we could see that the plots will show the diameter change on the graph. There are options to export to CSV or Excel. There's also an option to generate a report which shows an image of the plots along with any notes and measurement values from your measurement.